Fender Blues Junior. This one's in for a repair. Let's plug it in and see. We don't need to use the variac because it's been switched on recently, so we'll just plug him in and have a listen. Switch him on. So this is one of the lacquered tweed ones. Oh, yes, it needs some capacitors. Yes, that's very noisy, and all the controls turned down. It's a dead giveaway. So the capacitors are failing, and it'll be those dreaded IC capacitors. So what I'm going to do now is take the back off. We're just going to have a look at the condition of these tubes. So we've got the back off. So the dreaded IC capacitors here, we've got 447 at 450, and then we've got these three at 22 at 450, and it'll be that's failing, I would have thought. So let's just have a look at the tubes. Someone's been in this amp a few times. You can tell by the screws on the back plate screws are quite worn. They've got no markings on them whatsoever, but I've had that bit of a label on there, so I'm guessing that those were groove tubes very early. They could be the original tubes, you know. And here again, same thing. So we can bet they've had some hammer. The board for the tubes, because remember they soldered it on this PC board, that looks in good condition. Don't see any dry joints, and I don't see as that's ever been soldered before. It looks factory. Right, so let's just see if we can get in. Let's get a bit more light there. So if we look, we can see you can see these caps here. I don't know whether they've been changed before, you know. Whether they have or not, they've not been put in very well. That's shaking about, you can see, so that needs addressing. And while we're in here, we'll mod this amp, because while we've got the board out, it doesn't take up much more time, and it makes these amps sound so much better. All original, except those are the only suspects. But I'm guessing they are original, but I don't know. But they've certainly not been put in very well. So yes, just a case of getting the board out on this and giving it a good going over, I think. Well, we've got this out on the bench, and it's gone quiet. No more humming. So we don't really know what's causing that. Have we got some dry joints, or double digents as I call it? So I'm going to check the filaments. That's the first thing, and you know why, don't you? 6.86, 6.89, so 6.9 volts on those filaments already. So we know this is wired for 230 volts. There's no question of that. $272 volts. What we got on the plate then? $271. So 271 volts on the plate. That's low. Right, put the other light on. Right, I've just took the tubes out of this. I've got 357 volts without the tubes in, I've only got 271 with the tubes in. Something is drawing down that voltage. I'd expect to see about 325. And this cap here is a little warm. So something is drawing down this voltage. Is it that cap? And I really need to find this fault before I get this board out and start stripping this down, because if it turns out to be something else, I'm going to have to take this board out again once I've recapped this amp. So what I'm going to do is snip out that capacitor there, and I'm going to tack another one in just to see if jump one in to see if it cures that problem. Right, so what I've done now is I have jumped in the 47 microfarad cap, because I did a bit of testing before I cut that out and the readings were iffy, and now I've cut it out and put another one in. I've got full HT voltage and that cap measures open, but the strangest thing is wasn't making a lot of noise. In fact, it wasn't making any noise. Now I wonder if that's because I've got it on the variac and the variac's somehow smoothing that current and making it, well, just look, we've lost the noise. But it tested open. So our friend here is toast. No surprise with those caps, they were dreadful. And this amp is from a period of when they had the bad batching. I'm surprised they've lasted as long as they have. So now when we test, we've now got 324 volts, 322, 324 we've got. So we've now got full HT voltage, because of course with that cap being open we will be losing a lot of voltage there because there'll be no charging. So now we've got that, let's do our bias test again, which is what we wanted to do. And again, I needed to find that fault before I took this board out, because if I put it back in and that fault's still there, then I've got to take the board out again and start fault testing. But before I take it out, so I might as well do it now. I know now that I've found what the problem is, but we're going to do a full recap on this amp now. It's these caps are shot. It would be ludicrous to leave any of these capacitors in here. These 22s, obviously the 47, we know that's done anyway. So let's just do a voltage drop now across there and see what we've got now. Now we've got 2.47 on the Blau, and we've got 3.57 on the other side, so we've got quite a discrepancy then in those tubes. 2.7 and 3.57. Right, again, we're only doing this rough, we're just trying to find out how this amp's set up and so on. Nothing 3.57 on the right, and the left is 2.7. Now we've got voluptuous amounts of HD there. $321 we've got there. That's still only 28 milliamps. So we've got 9 watts at idle, so we should have 8.5, so that's about right. That's not a million miles out. However, the other side may prove to be a little different. 12 watts, as we thought. So yes, one side is only 9 watts, and that's 12 watts at idle. That's ludicrous, but that's about the norm for these. We've checked the let's just check the filament voltage again. Yeah, we got 6.9 on the filament, so we know we need to change the voltage selection. So what have we gleaned from this? Well, one of the tubes has really tired, because we know these are normally biased at 12 watts. The voltage selection is at 230 volts, that needs changing to 240. It needs a set of output tubes really, and it needs a complete recap because these caps are shot. So that's what this amp needs, I'm afraid. Quite a bit of work. But while we've got this amp on the bench and we get the board out, so we'll do some mods on this amp as well. Right, so we know what's wrong with this Junior, and we're now going to recap it. It's been a couple of days, well, it's been more than a couple of days, it's been about 4 or 5 days, been waiting for some parts and waiting for these caps coming. I want to change these two that are in here that are wobbling around. I think they are the original ones because they are IC caps. So the first thing we've got to do to get this board out is we need to remove this over here. We just go in this board with that's got the speaker socket on and the foot switch for the gain control or the reverb, or both even, but certainly the reverb. So we need to remove that first of all. Right, so just this socket is ½ inch. And usually these sockets are quite big. We don't usually need to put a ratchet into them. In fact, that one's really loose. So we've got those. Now somewhere we've got, just move those valves. The Fender bass breaker box, which is now the Blues Junior box, to put the parts in. So the reason we're going to take this out is because when we move this board back, it ends up you're struggling to get the board out with this in place, and there's risk of damaging it. So it's just easier just to take it out and just gently ease that out there like that, so that's loose. I don't know whether I've covered this before in the previous videos, but there must be a lot of people that have covered this, how to take these boards out. So the next thing, of course, is now we need to get some of these wires off here, and it's pretty elementary really with where these wires go. So we've got, obviously we've got brown, and they are labelled on the board. We just look in there. You can see where I've just removed that one from. You can see it says brown there, and same with that one there. And you can you usually see where they go. I mean, once you've done a few, it's quite easy to see where they all go. You just get used to it. But the red is the centre tap from the transformer, and that's the one that doesn't have a plastic insulator over it for some reason. Not quite sure why. Now we've got a brown down here, you can see, and we've got a blue there. Those two are the plates for the EL84s from the output transformer. So we need to remove those, or will we get away without removing them? Because we're not going to take this board completely out, because to do that we've got to take out this board as well to get the whole thing out, and I tend not to do that. I tend to just turn them over and just leave them tipped, because if you take this board out and this board, you've got those, you're turning the board upside down, turning it the other way, and these are dangling on these strips, and these strips are a bit flimsy. Whereas if you take the board out and leave this in, this small board in, you can just tip it over, wedge it with something. I usually use these cardboard tee boxes that I use. Wedge it with something cardboard, don't use anything metal because it damages the board, marks it. And then it's in one place, and then what you're doing is you're working either side of that. Let me just pull the camera back. Then you're working either side of the board, and you're not having to move the board around such a lot. That's the way I've done it anyway, and it works okay. You start getting problem with these ribbon cables, and yeah, you really will have problems with these. Some people remove these ribbon cables and wire them in separately with separate cables. It's a lot of work, but it does improve these. In fact, there is someone actually manufactures a board for these, and it's a really good quality one, and it eludes me who it is now. I've got a terrible memory for stuff like that, but you can buy it as the board, and it's really good. And I'm not as sure as it doesn't have the screen resistors and everything on it. I can't remember now, or it's certainly got, because I don't know whether this amp has got screen resistors, and that's just something else we've got to look into. But you can go on forever with these Blues Juniors, and you can turn them into a really first-class amplifier. You know, these amplifiers have had a lot of flack over the years, and you can see why in some ways, but you know, mod one of these and get rid of all the problems that they have with ribbon cables, and this board can be a bit iffy. This one's pretty good, and you've got a really tidy amplifier. Some people just rip the board out and hand wire them. There's a guy online used to do that. I don't know whether he still does it now. Rat Amps hand wires these, but anyway, I digress. So we've got two green wires here, and they are the filaments, and they are rather, and I try and get these off by hand rather than using the pliers, as the pliers is a last resort. I'm a bit tied up there. And then we've got two here. This is these two in this corner here, we just hone in. That's the AC feed, the ones that say red on there. They're the AC feed, so we'll take those off as well. I'll just get that board out of the way. There we go. So we've got those off. Now we also need to get the pilot light out here on this. You probably can't see that very well down there. Maybe you can, I don't know. So we need to get out that pilot light. Right, so we've got this pilot light out, and you need to take this out again to get the board up. And if you look on here, you've got these clips, and what happened, they just, as you're not going to push this in, but it clips around that lip on there. So you just have to ease these clips up to get that out. It's not a big job, that. We'll pop that in our box. That lens. So I've got those. So we will need to clip this tie wrap on here. With my much smaller cutters, which stops Gooden from telling me off. She told me off using the bigger ones. On a job, you need to get some smaller pliers. There were actually smaller cutters that was already on order. So he keeps me on my toes, though, does Gooden. Now again, we've got this bunch of wires on here, you can see, and again, these are all marked which ones they are. So we've got black, green there, and that one should be black, yellow. And is it marked? Let's just take it off and see if it is. My days. And that's actually not marked. black green is marked, but that one is. So that one is P10. So what we're going to do with these is P10 is black and yellow, and we're going to write these down. So it's just so we know. I mean, obviously I've got the camera, and I can go back and look on the camera, but let's pretend that you're doing it and you don't have a camera. So we've got P10 there, so that's black and yellow. Let's write that down. And then this one is P9 is black and green, but you can still write them all down if you wish. Just you know, black and green is P9, and then we've got black and red, you can see on there, and he's written down as well, black and red. 8 was blank, so again you can just put that 8 is blank just on there. There was nothing on 8. So you got 3 wires there. P9, P10 we know is black and yellow, black and green we know, and black and red we know. 8 is blank. So now we've got this P5 here, and the reason some of these I'm guessing are not labelled is because, oh dear, that's one's off, is because some of them obviously their orientation changes depending on what voltage selection you're going to have coming in from the wall. So we've got black on P6, so P6 is black. Now, which also brings us back to later when we're going to check the way the voltage is done on this. Most of these, as we know, are wired for 230 and should be 240 in the UK. P4 is also has got no colour label on, so P4 is purple, so we'll write P4 down. I mean, it's pretty elementary with the way these wires lay, you know, but it's still best to write them down. And P5, the last one, and he really is on, so he will have to be with the pliers. I hate using the pliers on these, but I'm afraid no choice with that. P5, I keep banging the camera as well, sorry. So P5 is white. So we've written all those down now, we've got those off, and that's good. And we will have to take these off, these plate the plate wires, because we've got to push this board back, and they are, if we look coming in here, we look in, and this is where the problem starts with this board. So here is where the wires come up through the transformer there. You can, whether you can see that, it's where the wires come through, and obviously that you can see immediately that's going to be taut when we push against it. So they've got to come off as well, and they are not coming off very easy either. So again, we need to sadly use these. And that one's off. So I only use these as a last resort. I really do try to pull these off, but sometimes you just can't get them off. Well, not when you're weak and puny like me anyway. And this one comes off as well. Now there's also a tie wrap around those wires, and I usually cut that off because it's really difficult to get this board back if you don't. And you're just going in there, and just be careful when you go in with your cutters that you don't cut the wires. It's very easily done. And there we go, and then we just need to get him out. Usually those a bit longer. That's it. So there we go. So that's now, we've now got that from out of there, and here, also some wires there as well. Just looking at those. So we've got those from there. Now there's also a ground wire here. So if we hone down this side, you can see we've got a ground lug there. So we've got to take that out as well. So we need a screwdriver for him. That's good. So that screw goes in our box. So now I've got that free. So the next thing is the controls, the knobs on the pot. So we need to get rid of. Now some of these have a screw in the top, and some don't. And this one, by the look of it, doesn't. So I'm assuming that these pull off. But that doesn't want to come off. None of them. Now, if you struggle to get some of these off because they just pull off, is if you get some wire like this and just hook it into the centers and pull, and they should. Famous last words mine. Some of these are on, and boy are they on tight. They are on. There we go. Don't put the screwdriver behind them. It's the worst thing you can do. Damages the faceplate, and there's such a lot of distance as well between the knob, because these knobs are quite far off the board, and you'll just end up marking it here as you're trying to lever it, and you'll probably snap the pot, really, because the thing is, when you use the wire, you're almost getting the pressure you're putting on it evenly across the pot, where you're doing it this way and you're pushing it at one end, and you might even end up snapping the shaft, which would be catastrophic. So you can end up making yourself even more work. So if we do that again, you can just see, get the wire like that. My word. Or even if you can't, just keep it shut, put your thumb there, and that usually pulls them off like so. Now the ones that have the screw in the end, they have a little washer that goes in to pad these shafts out, because there's a lot of play around them. But these pots have already got them built in by the look of, sorry, these knobs have already got that built into them. My word. Whoa. There we go. Oh dear. And you see, using this wire, it won't scratch or damage this faceplate at all. And that's how we do that. That's how we get those off. So the only other thing left to take off now is this. That's the wrong size. It's this socket here, the jack socket, and again, they usually come off by hand. So you get your washer as well there, and put those in your box with your knobs and all the rest of your bits. Now the last thing we need to take out are the screws, and that's pretty elementary. Long screwdriver. There we go. And these again come out pretty easy. And yes, the screwdriver is immensely long, and because they're actually mounted near the door where I'm working, and I just grab them out. Despite being long, they're really useful. There we go. Put your screws in your box. Just do this one as well. Oops. Go along, we've got one there. Right, So now I just have a check round just to make sure that I have got all the screws out, and just move the board gently either side. Just move it. And of course the other thing to remember if you are going to attack this is to make sure that the caps are drained, that there's no voltage left in the caps. We always that's one to always make sure of. There's obviously no voltage left in that cap because it's not in there anymore. So now we come to the tricky part now, is getting this board out. There's our star washer there. Put him in the box. Right, I'm going to turn it around this way. And you have to be really careful when you're doing this, because there are a lot of things that you can break. And oh, just noticed a wire there. Now what? I've just realized, this is what I say, you have to be really careful when you're easing these out, because chances are there'll be something that you still need to remove. And if we look on here, we've got this black wire here, and that is on the switch, and I've just remembered that now as I've but the fact is that, you know, I found that without yanking away at it. You just move that, and then we just pull that off there, like so. So that's come off the switch. There's only one off there, so you'll know which one that goes back to. And that's just the black wire. And now you can see we've got a little bit more freedom. So ease it gently. There'll be something you've forgotten. And there you see, I forgot that. But if I'd have been yanking at it, trying to pull it out, then you're yanking, and next thing you've snapped this wire off there. So it's just a matter of taking your time when you're doing this. The other thing you've got to be careful not to break is the jack socket. They're quite flimsy, so you've got to be careful you don't break that. Some people swap those as part of the mods. So I've now got my fingers under the board, and I'm using my thumbs to push against the edge of the chassis there. Now this side's pretty free. This side has got the age-old problem of these wires here. So you need to get these, I'll just pull that back so you can see. So these wires that are off the transformer wires now, off the plates and the center tap, you need to get these over here, and we need to flatten them down as much as we can to that one there. Just untangle them all. That's it. And then we need to get those down there as much as we can, because we've got to get the board over the top of those, and that's not easy. There we go. Now when you get the board back far enough, you'll be able to get your fingers down the front side of the board, and then it's much easier. And you can see now we're sliding those across the wires, and now we just try and see if we can, that's it, lift the board here, keep so we're not digging into those wires too much, because we don't want to be doing that. Right, so we've got this reverb coming through here, and what you've got to do is try and get the board over that. Just got to lift that and get that. You end up getting it trapped there just for a second and again. So now we've got the board back so far. The pots now, as you can see, have now cleared the chassis, and we now need to start to ease this back. So the only thing now that's really holding this board back is the wires down here. So you have to make sure that these wires under here, you can see that are really as flat as you can get them, and the board's going to go over the top of them. And now if we lift the board, you can see the pots are into the board, and I've got the board lifted with my fingers. So put your thumbs on there like that, and then ease the board out. That's good. Turn the amp round, the chassis round. So that's how we do that. But as I say, the secret then, you can see that, you know, how careful I was there, you know, as we butt up to things that are stopping the board coming out. If you go in hard at it, you'll probably end up breaking something. So the last thing you want to do is break the board as well. That's really that really would be catastrophic. So then if we get this box has got a bit squashed, but we just pop that box in there while you're working on this half, move it down to the other side. We use these cardboard boxes because they don't damage the board. If you put something in metal, it's moving around while you're working on it and it just gets damaged, and they work well. It looks Heath Robertson, but it actually is, it's really a safe way of doing it. You're not going to do any damage. Right, so we're now in a position where we're ready to start changing the caps. Right, so we'd already got the old cap removed because, remember, we tripped it out, and we tapped in jumped in a new one just to, when we were doing the fault finding. So when you come to fit this cap, you'll find there'll be some hot glue under here. You need to scrape all that off and get it really clean. Get some alcohol on it or something, get it clean. And what you need to do is make sure that the holes are free from solder on the board. Use a solder sucker if you've got one. And when you bend these pins for this cap, it need to have it so it just drops in like that. And the reason for that, I do that, is because we're going to put some hot glue underneath here to bed this cap on, and then we're also going to put some more down the sides to hold it in place so it's more firmly held in. And the thing is, if it drops in dead easy like that, then it's very easy to lift it up, get the glue on quick, drop it down, and then just hold it till it sets. Whereas if you've not got these bent quite right and it's a bit stiff going in one way, but you're wriggling, you know, you're jiggling it to get it in, by the time you've got it down there, the glue's offset. So, and also if it just drops in nice like that, there's no strain being put on these ends. So it's that's just the way I do them anyway. Right, there we are, we've got the caps in. So we've got that one glued in. As I said, we've put some up the sides. Now when you put these in, what I always do is, obviously we seat it on some glue, and then I put some down the side of that one, down the side here, seat the next one, go down the side of that one, and so on. This end one I haven't put any glue because of getting a bit too close to these. I don't want it all gunking around these spade terminals. But what I have done then is gone down the middle of them and filled them with some more hot glue, and that keeps them solid. They're not going to move. We don't want those moving about. So that's the main electrolytics done, and they're F&Ts, so we've put good quality stuff in there. We'll make this amp as good as we can make it. So the next thing we're going to turn our attention to now is these two caps here. Just hone in there. So these two are the ones that are wobbling around, and without looking on the schematic, I'm not ever so sure what they do, but they're old electrolytics, so they're coming out anyway. And seeing as I'm just going to swap them anyway, I can't really see the point in sitting and reading the schematic for 3/4 of an hour, fathoming out what everything does. Let's just get this amp recapped and get it back up and running. Right, we've got those two in there, and those were those two there. That was 50 volts at 470 microfarad, and we've got 470 at 63 in there now. So we put those in. You can see I've got those well glued in. Now when I put these caps in, what I don't do is hold them down with this hand and then try and solder them with one hand and get them into place. That's what a lot of people do. What I do is glue them down, hold them down tight till the glue's dry, and then solder them up properly, and then that way you get a decent solder connection. It's what most people, some people do, not, I mean, everyone does, but some people will get a bit of soda on them, and then what they'll do is they'll press them down hard, they'll go back to the soda, and then resolder them again. And you really don't want to be doing that to get a perfect solder joint. You want to be going in with the solder and the iron, soldering them, and that's it. You don't touch them again. If you do, then you're touching them up with the solder, but not just with the iron on its own. That's the way I do them anyway. So I glue those down. You see they're really solid now. Now I've got a couple here. These are 220 microfarad at 25 volts. And I've just had some 220 microfarads at 35 volts in my hand somewhere. Let me just pull that back on there. So I've got this under here as well. So when we you know, obviously we're pulling this board down when we're getting these caps in, and we don't want to be scratching the tracks, you know, on the board, on the edge of the chassis, which is why I've got that in there. Whilst it does look a bit heath, it's very effective. It's full of dry wipes, so it keeps it well cushioned. So we don't want to damage the base of that board. So here we've got these 35 volts at 220 microfarad. They will be going in place of those two. Now I'm hoping I have got all of these values, although some of these caps don't see a lot of voltage. We don't really know how old this amplifier is. I bought one of these in 2017, so you know, it may only be 2016, 2017. It's not massively old. But those IC caps haven't lasted long, have they, really? If you know, if this amp were bought, say, 8 years ago, they've really not lasted long at all compared to some amplifiers. So there's those, and then there's one here, which I'm not sure what that one is. That's 100 microfarad at 25 volts. I would have thought we've got something to go in there. And then we've got, you can't see because my hand's in the way. And then we've got another one here which we need to look at, which somebody's very kindly put the value at the bottom, so I can't read it. And then we've got one here which they've also put the volume to the bottom, so I can't read it. Or can I just see that one? 22 microfarad at 35 volts. The other option, of course, to go and look on the schematic, but I'd rather not if I can see them. And we've got a 47 and a 22 here, so we should have all of those. So we should be able to do a full recap on the, you know, on the aluminium caps. Should be able to do a full recap, which is good. So I'm just having a look round. Anything else? I can't see any burnt resistors or anything like that. And we know this amp runs, and we know what the fault was, so we've already diagnosed what was wrong with it. So it's looking pretty healthy. Now the other thing we'll be doing is we're going to mod this amp, because these amps, and I've done this before, and I've done these Blues Juniors before, but these amps can be improved greatly on the EQ. So there is some speculation that Fender made these amps in a particular way so they wouldn't compete with their next level of amplifiers, like the £700 plus range or $700 plus range. I don't know, they may be a bit more in the States, but anyway, these were around £500 when they first came out, and you got amps that were like £700. And obviously, these being a very popular amp, Fender, that's what the speculation is. Fender didn't want these amps to, you know, to sound as good as the £700 odd amp. Seems logical, doesn't it? But you could make these amps sound great with just a few tweaks and a few changes of capacitors and things. And that's what we're going to be having a look at next when we've finally got this recapped. Right, so we've got all these caps in. You can see here, all these. They're all glued in and sorted. This cap here is only on the reverb, and it's only well, it's doing virtually nothing. It's not seeing any voltage, so that one will be fine to leave. This one also will be fine to leave. Now this one I have swapped, because that is the bypass capacitor on the first stage. You can just go in there, you can see it, and that was 47 microfarad, and I have swapped that to 22 as part of these mods. And the reason I've done that is I'm going to take some of the mods that I'm doing on this amp from the Fender Princeton. And you can, you know, I mean, obviously a Fender Princeton, it has got a cathodione phase inverter, but most, you know, whether it's, I think the Blues Deluxe has got the long tail pair, I forget now, but I think it has, but they all share roughly the same components in the preamp stages, most Fender amps. And you do seem to have a bit of mushiness on that first stage, especially when you're using the gain, you know, you get the gain up. So I'll move that, just drop that down to 25 there, put a nice Vichet in there for that. Now, one of the a couple of the things in this amp, in fact, a couple of the coupling capacitors in here, they use 2.2 nanofarad, which really they should have used 22 nanofarad. And that's, again, one of the things that is rumoured to be how they made these amps not sound quite as good. And I have to be honest, I used one of these amps in 2017, and with a Strat or a Telecaster through it, it was absolutely legless. And when I modded these amps, it just transformed them. You just couldn't believe, you know, how good it made them. So people have got these amps, but when you have them modded, you know, if you've got a Gibson, you know, Les Paul or an SG or something playing through them, and I ended up using an SG through it at the time, and it was okay. But Fenders didn't sound particularly great through these amps. You know, Strats, Telecasters didn't sound particularly great, but they do when they've been modded. So we're going to use, you know, we're going to do the Princeton tone stack in here. There's a mod that we do on the mid control, and one or two other capacitors that we're going to swap, and this amp will be smoking hot. So the first thing we're going to change, and if you've got one of these and you're going through it, then get a pen and write these down as we go through them. The first one is C2 on there. Look at that. Now C2 is 2.2 nanofarad, and that's way too low. We want that to be 22 nanofarad. So we're going to change C2 first. There's the 22 replaced there, the 2.2 replaced with the 22. And when you put these in, make sure you suck off all the old solder on the tracers, and don't try and force the cap in if you've left some of that on, because if the hole's not big enough for it to go through, you'll push it and you'll just pull the trace off, push the trace off the bottom of the board, and you'll have more problems. The other thing is, these, if you look at these caps, they've been placed right down onto the base of the board. If you look at this one, I have just left it up slightly, and the reason for that is that in the future, if a tech comes in here and he wants to be testing, he can get his probes under there and test the caps for leakage in years to come, where when they're all flat down there, you can't do that. So all the ones that I'm changing, I'm going to they only just leave just a 2 or 3 mil, just enough to get the probes under 3 mil maybe, and you'll be fine with that. Just makes it easier for the next guy that comes along. Now also C8 is also a 2.2 nanofarad, which needs to be 22, and C8 is protruding down there. That's C8, so we're going to change him as well, same thing. And then we're going to move on to the tone stack. Now we've decided to put a Princeton tone stack in this, where it's probably in most of the Fenders, but and the caps for the tone stack are there either side of that bass part, C6 and C7, so we'll also be changing those. But first of all, we'll change C8. Right, so we're looking at the Blues Junior schematic, and we're looking at the tone stack that we've got in there, and there's the two components that we're going to change, and that is C6 and C7. Both of these caps, you can see here, C6, C7, are both 22 nanofarad, 0.022 microfarad. Now we are going to change C6 to 100 nanofarad, which is what's on the Fender Blues Deluxe Princeton. So we're working off, I'm now working off a Blues Deluxe schematic. Most of the preamp sections are the same on them. So we're now going to make 0.022 is going to be 0.1, 100 nanofarad instead of 22 nanofarad, and the 22 nanofarad down here, C7, is going to be 47 nanofarad. So C6 and C7, 100 nanofarad, 47 nanofarad. Right, so we've got those two caps in the tone stack. The next thing we need to look at is coming from the master volume. Got a 220k resistor, and we've got a 33 nanofarad and a 0.01, and that's going into the phase inverter. Why this 0.033 33 nanofarad is here, no one seems to really know, but a common mod is to remove that, and all you do is put a jumper in there. So a slight problem in the fact that C10's right at the bottom of the board, so this one's a bit of a swine to change. You can see him down there, that's the chap there. But we're actually, so what we're going to do is we're going to remove him, and then we get, and one of the things you could use for this is what you've cut off your capacitors. All we need is a piece of this, and all we do is we shape it to fit in there, and then we just solder that in. So the first thing is to remove the capacitor. The next thing to look at is this mod on the mid pot. Now this gets rid of the boxy sound that these Blues Juniors have, and it's a very popular mod that's done on these amps. Now you have to bridge two of the pins together, and the easiest way to find out which two, obviously the center one is obvious because you're going to bridge the center pin to either of those two. Now what you don't want to do is bridge this to ground, so we need to find out which one of those is ground. The easiest way to do that is the wire that we took off the earth lug there. We put one of the probes in for the meter, and we come back in and focus on the middle pot there. You can see now if I put my probe on the right one, I get nothing. If I put it on the left one, I get continuity to ground. So that tells us we need to bridge the middle one and the right one. So there you can see I've bridged that across there like that. And make sure you put this piece of wire underneath these two pins, not above it, or you're getting a bit close to the ground there on the pot. Right, one other mod for this amp that Lee mentioned at the shop. One of the problems with these amps is the reverb control is a bit all or nothing, and there is a mod to improve that. And what that mod is, if we go to R44 and we add an 82k resistor over it, and I don't know who came up with this mod originally, but I know Lyle Coleman has done this mod. So whether it was Lyle that came up with it, I don't know. Now I thought, while I've got this board out, basically what we're doing here is we've got a 220k resistor, that's R44, and we're adding an 82k resistor in parallel. So what I thought I'd do while I've got this board out is measure what that final value is, and it comes out at 59.8k. So why have I done that? Well, while I've got the board out, it seems silly tacking this resistor onto the top of that one if I could find a resistor that's closer to the value of what I've just measured, the two resistors together. And in actual fact, I think if I put a 56k resistor in there, because we're going to be all on finding a 59k resistor or a 60k, but I think if we put a 56k resistor in there, we'd be fine. Right, there we go. There's our 56k resistor in there on the reverb. So he's all done. R44, that is. If you've been followed all the way through that, you've just modded your Blues Junior. The thing we've got to do now is put it all back together. Right, we've got the board back in. We've not got the knobs on yet. We've not got the pilot light in. We've got most of the things. We've converted it to 240 volts on the transformer there, tap-ins. So I've got a small amount of voltage through it, and what I'm doing now is I'm just testing just to see with no valves in. So we've got 30 volts. I'm just working my way along these caps just to make sure we've got some bias. Yeah, we've got bias. So we are going to put some tubes in it now and run it up gently. Right, we've got about 120 volts now we've got up to in this amp, and we've got 173 on the first node, and we've got 155 on the second node, so it's conducting, but I don't have any sound. Let's plug something into it. Oh, we do have sound. That's good. So let's go up a bit more. And we'll go up to 140 volts. Now giving us 200 volts on node 1. 167 on node 4, and that's dropping now, so we really are getting some conductance. Yep, can hear sound. So we're just taking it steady as we're going up. 166 volts, 230 on the first node, 180 on the second. So I've got about 190 volts on there now on the Variac. 259, 196, just gone up to 200 volts now. 284, 210. Now these are a set of Softecs that I've got in this now. The guy who owns this amp sent with them. They're a used set, but I measured them on the meter and they absolutely pegged it. Whether they're a matching pair, of course, remains to be seen. Right, let's see what we've got on the filaments. 5.75, and we're at 209 volts, so that's looking good. Right, we're at 240 volts. 326 on node 1. 236 on node 4. 6.6 volts. So a little bit over, but not like it was before. It was 7 volts virtually. 6.9, it was 7 volts, so 6.6. So that's brought that down to a manageable level. Now there is one other mod we need to do on this amp. A 100 picofarad capacitor to prevent oscillation across the 100k plate resistor R30. So we need to add that. Now the later ones add that on, but this one doesn't. And in my experience, the preamp tubes don't last very long if you don't do that particular mod. Or should I say add in what should have been added at the factory. Mid works. there seems to be a fault with this base pot, and if you remember at the start of the video, it said that was wobbling somewhat. So I think that might have got damaged, and that's going to be a problem to repair, because I don't know whether you can get these pots for, I think you might be able to, but yeah, that doesn't didn't see any dry joints on the board, but the others are nice and taut, and that one is loose, so that one's had a bump, it has, inside, and it's we can try and squeeze the in fact, is that cracked? I need to get a magnifying glass for that. I think that pot is cracked, you know. Didn't actually spot that before on the like the Bakelite back that goes in. That looks like it's cracked to me. So it's all up and running. We've got a faulty base pot, everything else works fine, but that pot is faulty, it is damaged. But we did note, like I say, we did notice that had got some play in it, so it looks like that's all over. I was hoping we'd get away with that, although it was a bit jiggly. It did work all right, but I'm afraid, obviously disturbing it, taking it out, you know, taking the board out. Oh well, never mind. Well, this is why I didn't put all the knobs on and everything, put it back together. I've just put enough in to get it running. Right, so let's just have a bit of an assessment. So we've modded this amp. We've done all the mods. We've recapped it. What have we got left to do? Well, we've got to bias this amp, and that's going to be in part 2, because this video is getting quite long now. So we're going to do a part 2. We've got to put that capacitor across the 100k resistor on the phase inverter, the plate resistor for the phase inverter. That's no problem, we can sort that out, just for that oscillation. So we'll do that in part 2 as well. Now I've got to go in and find a base pot for this. Right, so that'll do it for this one. So look out for part 2. We're going to bias this amp up and give it a test, and we've got a mod coming so we could adjust this bias, and we're going to have a look at that in part 2 as well. But that'll do it for this one. So thanks for watching. You all take care, and I'll see you all in another video. Bye bye for now.